Okay, so let's start this section by drawing some nice diagrams here of a hub, a switch, and a router. So it's very obvious there, that's a hub in green, switch, and router here in black. Hold on, back up the truck there a second. Yeah, let's go over that again. Yeah, hub, switch, router. Okay, obviously you've got three devices that all look pretty similar to this box that you have here, or probably more sophisticated. So the difference obviously lies within. Start with the hub. So a hub, as you can see, is the small little box with a whole lot of RJ45 ports. They'll fit cables just like the one you see here, your normal network cable. May be better known to you as an Ethernet cable to your computing devices. Okay, so let's nominate a sender here and send a packet of data. So on a hub, when you send out some data down your line, the data that you send is broadcast to every single device, whether that device is intended to get the message or not. So we have a whole pile of redundant data there. What can also happen on the hub is if two devices are sending data at once, for example, if this device is trying to send data, we'll have a collision, and if a collision occurs, one device is one of the messages given preferences, and this data will be cancelled, and it'll have to be resent until it doesn't collide. So you can see that this model of sending and receiving data through the dumb box, as I call it, you're broadcasting a whole lot of unnecessary messages. There's a lot of messages getting out to unintended receivers, so you've got security issues there. You've got lots of collisions occurring potentially, so you're resending a lot of data, so a lot of unnecessary traffic there as well in the hub. So sometime in the 90s, hubs were probably the preferred method of connecting network devices like your PC and your routers and so on, and printers. At the time, the switch, which we're going to talk about in a minute, would have been a lot more expensive as a device. So most of your smaller companies or home networks would have been buying hubs and using hubs as their network connection device due to lower costs. With the market for hubs being quite large, a few different types of hubs were introduced to cover different needs. So three terms arose out of that: passive, active, and smart hubs. So the first type, passive hubs, are not more than a point of contact for the wires that make up a physical network. Active hubs then are a little smarter than your passive hubs. They both connect to network devices as well as providing a repeater function. So repeating the signal means you get the signal and you concentrate and renew the signal as you send it out. And finally, intelligent hubs, unlike the dumb one I'm describing there, would have been released at the time as well, where they contain some sort of software that help you find out some network problems where you can isolate and diagnose network issues. So next we'll look at the smarter switch. The switch takes advantage of the technology that's available on our computers that assigns every networking device with what's known as a MAC address. So you can see each computer here is its own address, which is a set of hexadecimal codes. Now the important thing we should note about these addresses that you see circled here, assigned for to each computer, is that they're unique to the networking device in that computer. So just say, for example, your wireless network card or your network card in your computer will have a completely unique MAC address compared to any other device in the world. So we can make use of this technology. When the switch is powered on, you can see there's different ports in the switch, and at the power on, then what happens is a thing called a lookup table is set up. So in the lookup table for this scenario here, each port then is assigned to the relevant MAC address. So as you can see here, port 1, when it's switched on, is able to pick up from the computer attached to it, or the network card I should say rather, attached to it, the MAC address of that device, and it assigns that MAC address to port 1, and so on with the other MAC addresses attached to each port. So let's send out a packet of data here, and the information that will go with that packet of data, I'll just send that packet of data out from this machine here, is the sender information, which just picks up the MAC address from the machine here. It also, when it sends out the information, gives out the MAC address of the receiver. Okay, so it sends it off there to the hub, and the hub will then know through the lookup table that the receiver MAC address there corresponds here. We got a hit, so it knows to communicate that message to port 4 and send it to the device that's going to port 4. So you see, you've none of this business that you have with the hub, where all the information is broadcasted out to each device in the network. It goes to its intended recipient. So the technology there that's important is the MAC address and the packets of information going out with the MAC address of the sender and the receiver. Why does the sender MAC address go out? Because if there's any bothers or problem with it, we know where to route back to error messages and so on. Rapid routers is our next topic here, and why I call them rapid is because they can speed up things around the network. They're even more intelligent again than your switch and your hub. They help you choose what path to take around your network and what's the fastest path to get to from one device to another. So you probably see a router having less ports on it because it's just at more critical junctions of the network deciding where the traffic goes. An example here could be also if you have a break in the network. So for example, if I had a break at this point in the network here, the router, if it was sending packets of data around and you're trying to get your packet of data from here to here, obviously you're reaching your break there, the router would reroute the information around the corner here, so it would be able to reach its final destination if it was out maybe on a PC attached to that switch. In this scenario here, so very intelligent devices, and there's a little more they can do on top of that. I'm going to show you how to hook up a typical home broadband router and just do a little bit of configuration, just to understand the bit of security maybe you could do with a router as well as the trafficking. Routers. I'm going to look at a real life router here, and I've taken some recordings of one I have at home. As you can see, it's plugged in with some lights on here. This is capable of wireless routing, and it's got some Ethernet ports here at the back. I'm going to use a biro here and just pop it into the reset switch at the back of the router. Hold it in for about 5 or 10 seconds. Once reset, you can see the lights flashing on and off there, and that just wipes the existing settings of that router for me, so I can reprogram it to do what I want and show you some of the capabilities of a router. I've got to put a bit of network cable there in the back of the router and attach the other end of the cable to the network port of my laptop. I've got my computer connected to my router. I'm just going to go into my browser and type into the address bar the IP address of the router. Of course, I got that by reading the manual for the router, and I just click in there and I put my default password in for the router. And once I log on, I can see some little bit of details about the router itself. The IP address that I just typed in, you can see here, is available. You can see it's able to hand out IP addresses here to other devices on my network. So any device that connects up to it will get handed out an IP address starting with 192.168.0.100. The next device that gets attached will be 192.168.0.101 and so on. You can see here, if I want to set up the wireless part of my router, I can get it to broadcast what's called an SSID or a network ID. So for example, I'll just go like my home, if I call it that, and I apply that change. It's going to reset the router itself. Now on my computer, when I search for my networks, there's a network called My Home. You can see compared to the other networks that are available, it's unsecured, so we're going to have to do something about that. So I'm just going to click and join My Home network, which I can remove my Ethernet cable and just refresh to confirm that I'm now connecting to the router via the wireless. I'm going to go into the security settings. I'm going to put in some encryption here, so that's password protection, and I'm going to choose the WPA protection, and I'll choose a passphrase. Rapid routers. So let's apply this. The router again will reset. Now you can see I'm unable to connect to the router because the security is in place. So I'm going to have to hit my network connection. Now you can see my network connection appears with security. So I'll just click the link on it, type in my password, and now I'm in. A very important part of Wind networking is sending data from one network to a different network. So the function of a router might be to bridge you from one network to another. As you can see in this case here, I have two Windows networks, and if you want to pass information from one network to the other, we've got the router there right in the middle to do that job for us. Now in your computer settings, you might see when a computer needs to send something from one network to another, you usually have it specified on the computer network settings. So for example, on my Mac here, you specified a router here that's going to get you from one network to another. So when you're sending a package outside of your own network, you know what your device is here from this address here. In the Windows network, the term default gateway is normally used, so you'll probably be specifying the device there, which is the last point of your network, or the router, which is the last point of your network that bridges you to another network. Now, another term that could be used here for a device that bridges one network to another is gateway, but it's more commonly used when you're connecting one type of network to a different type of network. So just to give you an example here, imagine you've just got a regular switch and you've got some PCs hanging here. Okay, then we'll just call that Windows Network C. And then on the other side of my gateway, I might have just one big giant mainframe computer here, supercomputer. With some dumb terminals hanging off of that. Just all hooking up to the power of the mainframe computer. Now the difference between the gateway and the router here is that the rules are the packaging of the information. The other side of the gateway here are what's known as the protocols. Here is different to the protocol or the set of packaging that's used for this network here. So we call that protocol A here and protocol B. So that's where a gateway difference from a router. If we go back to the network there with the router, we'll notice that the protocols are both Windows networks. So the router is only switching the same protocol or the same types of data from one network to another. Trying to beam our networks out over large distances. So in the examples I see here, at the top I've got a wired network where I want to connect one device to another device over 150 meters. I got myself a Cat5 cable here. Now the problem with this is Cat5 cables tend to degrade when I get to around 100 meters. So around this point here, my signal's going to fall off, and I'm not going to get a proper signal over to this device here. So for that reason, you might come along somewhere in the middle of this line, maybe about here, and decide to put in a device called a repeater. So a repeater helps us stretch that network out. So it essentially gets the signal, it's coming from this cable, and just renews that signal if you like. So if I put a repeater in here, increasingly lots of companies you may come across are trying to beam out their Wi-Fi over larger and larger distance, or get complete Wi-Fi coverage in buildings that might have tricky areas and so on. So your Wi-Fi, the most recent technology, wireless N, would typically fall over around 60 meters. So again, it would be appropriate at this point in the network to get a repeater in there so that the laptop will be able to receive some sort of decent signal from the source routing device over here. One thing to take note of when trying to do this in real life, if you like, is that the repeater devices should be the same from the same manufacturer as the original routing device, or the original signal device of the network. This would help you avoid problems with protocols and one device being able to talk properly to another and beam out the message. In this tutorial, we compared the switch, hub and router. The hub being described as the dumb box that sends message from a sender, broadcasts it to all devices attached to the same hub. The switch being more intelligent, uses a lookup table so it can get the sent message and find the port of the receiver and send it out to the correct receiver. Function of a router then would be to pack in even more intelligence again by knowing the quickest path or the most intelligent path to get from one device to another on the network. I then spent a little time showing you how to configure a home Wi-Fi router. After that, we reviewed the ability for a router to connect one network to another, provided that the protocols or the type of packaging the network data was the same. If the protocols are different, a device called a gateway is normally used, such as an example here with a Windows network connecting to a mainframe. After this, we looked at the problem in network of the network media and the network cabling falling over certain distances, and the use of a repeater to help out here to renew or to refresh your signal. Finally, we took a look at servers, similar in built to PCs, but probably with more horsepower than PCs in terms of RAM, processing power and so on, and also with a different operating system that would enable it to first and foremost manage authentication so the user can sign on to a network, and then it would various servers often would manage sharing resources such as printing files, web pages, organizing email for a company. And then the final device we took a look at the end of a network is a firewall, which enables you to set some rules so you can decide what information you're going to allow into your network and what information you're going to block.